We once believed we had a firm grasp on the workings of the universe. The expansion of space seemed to be settled science, clear, measured, and predictable. But recent discoveries have shaken that foundation to its core. The combined observations from the James Webb Space Telescope and the Hubble Space Telescope have delivered results so perplexing they may represent the most unsettling confirmation in modern astronomy. The universe is not behaving the way we thought. The models we've relied on for decades are beginning to crumble. Where once there was consistency in measurement and theory, now there is contradiction. Even more alarming, there could be a force beyond the observable universe itself, something unknown, disrupting the very laws of physics. It began with a bold initiative to merge the infrared capabilities of the James Webb Telescope with the sharp visible light vision of Hubble. This would allow astronomers to peer deeper into the early universe than ever before. But instead of clarity, what they found were anomalies. One such discovery was the galaxy ZFGS 7329, so massive and ancient it defied all established cosmological models. According to what we understood, the early universe simply didn't have enough time or matter to create such a structure. And this wasn't an isolated incident. More galaxies were identified that seemed impossibly large and well-formed. Black holes appeared that were too massive for the age they were supposedly born in. But perhaps the most jarring revelation was this. The rate at which the universe is expanding isn't consistent. It changes depending on where we look. Astronomers have long relied on a value known as the Hubble constant to determine the speed of the universe's expansion. But now, measurements from Hubble and James Webb, observing Cepheid variable stars and distant galaxies, are in direct conflict. These aren't minor differences, they are fundamental contradictions. Adam Rees, a Nobel Prize-winning astrophysicist, remarked that if measurement errors are ruled out, the only explanation is that we have fundamentally misunderstood the nature of the universe. This discrepancy undermines the core of the Big Bang expansion theory. Some call it attention in data. Others now call it what it appears to be, a full-blown crisis. As scientists scrambled to make sense of the data, one physicist, Rajendra Gupta, proposed something radical. The universe may not be 13.7 billion years old as we've believed. It could be nearly 27 billion years old. He suggests that we've misinterpreted the very nature of space and light. According to Gupta, light doesn't just stretch over time, it also conceals information. This idea challenges the existence of dark matter and dark energy, claiming they might be artifacts of a misunderstanding. In his model, there's no need for mysterious forces to explain cosmic acceleration or structure. Instead, it suggests a more profound error in how we view the vacuum of space. If Gupta is right, foundational pillars like Einstein's general relativity and quantum field theory may need to be rewritten. Others in the scientific community are exploring theories that venture even further. One possibility is that something from outside our universe is influencing it, a neighboring universe exerting gravitational pressure beyond the bounds of what we can see. This idea, grounded in mathematical modeling and supported by Webb and Hubble observations, may explain why the laws of physics seem to unravel the farther we look into space. The implication is staggering. We may not be alone, not just in the context of life, but in the very structure of reality itself. For years, the concept of dark energy provided a convenient explanation for the universe's accelerating expansion. It filled the gaps in our understanding and allowed existing theories to hold. But now, the data is tearing that explanation apart. If the rate of expansion varies across different regions of the universe, and if galaxies are forming much earlier and faster than previously believed, dark energy may not exist at all. If that's true, then 70% of what we thought made up the universe was simply a misinterpretation. This isn't a minor revision, It's an existential identity crisis for cosmology. Despite the magnitude of these findings, official responses have been muted. Space agencies like NASA and ESA haven't issued formal statements acknowledging the potential collapse of key theories. Instead, they've opted for vague comments about the complexity of the data and the need for further analysis. Behind the scenes, however, insiders report private meetings among international cosmology bodies. One leaked internal memo allegedly described the situation as a paradigm destabilization point that should not yet be publicly acknowledged until the broader implications are assessed. The hesitation to go public may stem from the fear of what such a declaration could trigger shifts not only in science but in philosophy, religion, and global priorities. Some researchers now believe the root of these inconsistencies may not lie in space, but in time itself. According to this idea, time might not flow uniformly across the universe, depending on factors like matter density, quantum fluctuations, or even interactions with alternate dimensions. Time could be moving at different rates in different regions. This would make distant galaxies appear older than they should be, because they're existing under a different temporal framework. If true, it fractures the notion of a universal timeline. The Big Bang may not have been a singular beginning, but a ripple in a much larger, multidimensional event, one in which our universe is just a wave. There's one more theory that's beginning to gain traction, though it's rarely discussed outside of elite scientific circles. It's known as the cosmic phase transition model. In this theory, universes undergo fundamental changes in their physical laws, similar to how water can freeze into ice or evaporate into gas. The anomalies detected by Webb and Hubble might not be glitches, but early signs that our universe is approaching such a shift. If a phase transition is indeed coming, it could happen over millennia, or in a matter of moments. When it does, the rules we take for granted, how light travels, how gravity works, even how time flows, could be rewritten entirely. Reality itself would change in an instant. For over 100 years, humanity believed it was uncovering the truths of the universe. We mapped its expansion, chronicled its origins, and inscribed its laws into textbooks. But the revelations from the James Webb Space Telescope suggest something far deeper. We weren't discovering the universe. We were only seeing what it allowed us to see. And now, those illusions are dissolving. The constants we trusted are no longer stable. Time may not move forward evenly across space, and the vast emptiness between galaxies might not be empty at all, but filled with something far more complex, possibly even alive. What we once labeled as dark energy could be nothing. What we assumed was background noise may in fact be a signal, and what we thought was random expansion might be driven by a force we have yet to comprehend. We're no longer just asking how the universe began. We're asking whether it's still beginning, or perhaps if it's preparing to end.